distinguish between boiling and evaporation. But that is too bad. If you cannot say at least a point to distinguish boiling from evaporation. That all? What is humility? Because he gave one, but it was not correctly given. You cannot write like this and get it in the wire. There are two ways you can distinguish. If you say evaporation occurs at any temperature, you are expected to join it by saying one boiling occurs at a fixed temperature. If you don't have that conjunction, if you don't have this, you will not be mad. There is another way you can write it and get it. That is by tabulating. You tabulate it. You tabulate. You have evaporation. Evaporation. Now you have boiling. That's another way of writing or distinguishing it. When you tabulate like this, you can write, you can say evaporation occurs at any temperature. Evaporation occurs at any temperature, while you can say boiling. Boiling occurs at a fixed point. Yes, it's either you say it like this or like this. But you cannot just write it separately the way it's written. I will give one or two more points to this. Then I will still hold you responsible. I will still hold you responsible. This is what you can pick from your textbook. It is not too much for somebody to be able to say that evaporation takes place at the surface. It is a surface phenomenon. While boiling takes place throughout the body of the liquid. It is throughout the body. When liquid is boiling, it involves the whole body of the liquid. Whereas evaporation only takes place at the surface. These are what you are expected to see when you are asked to pick some things about. And when do we say boiling occur? When the saturated vapor pressure of the water or liquid equals to atmospheric pressure, that's when we say the water is boiling. The temperature at which that occurs is now called boiling point. Temperature at which the saturated vapor pressure in the liquid is equal to the atmospheric pressure. That is the temperature at which that occurs is called boiling point. You can also talk about factors affecting evaporation. Then what affects boiling? These are things I expect you to pick when I told you to read about evaporation, but some of you did not. Just like I said last class, this does not require any calculations. I have some other topic I quickly want to touch that has to do with calculations. So I will take my time to go straight to those topics. But before the topic, we are talking about heat, specific latent heat, and I gave correction of some of them last class. I think with the correction I gave, I expect serious students to have solved as many as possible from his or her textbook exercise on the topic. If you have done that and you have a question posing problem, I think somebody brought a question that day, but time did not permit us to lay hands on the question. If I have the question, then I told the person to give you the question so that you can go through the question and see. I want to encourage every one of you to work exercise and bring your difficult question to the class so that we can see it together. So, have you been given the question? Did you give them the question?
Yes, sir.
So, have you tried the question, everybody? Question number 2. How many of us here have the question with you? Hot water at a temperature of T. Hot water at a temperature of T is added to twice the amount of water. Twice the amount of water. At a temperature of 30 degrees Celsius. If the resulting temperature of the mixture is 50 degrees Celsius, calculate the value of T. I take the question again. Hot water at a temperature of T is added to twice the amount of water. Twice the amount of water at a temperature of 30 degrees Celsius. If the resulting temperature of the mixture is 50 degrees Celsius, calculate T. Now that's the question. Who wants to solve the question for us in the class? you working it? Your exercise, or what is it? I said we want to solve the question in the class. Please look straight, look at my face. Don't pretend you're writing anything. Here is the question before you. Who wants to solve it on the board? That's good. Only one person. Please take it there. You are told, if you don't practice this thing at home, it may be difficult for you to be able to solve question on that. You try question even if you miss it. Imagine you are asked to research, learn evaporation and boiling, humidity, dew and dew point that has no calculations. Some of you did not do anything. If I should ask you to show me calculation you did on this topic since Monday to today, I'm sure you have nothing to show. She responded last class. She responded to question last class. And I'm not surprised because she's trying it. That's why she's able to get the question she could not solve. She has only one head. Even if you miss it, it's when you try, you become expert. And I've told you it's not when exam is a week, or you have exam tomorrow that will now learn everything in physics, or in science. It's not done. That can be done in art. All you need to know is font and develop it. But science is not. You have to learn things bit by bit. You don't know. I am going to give this one in form of question, and it must be submitted next week, Monday. Disagree between boiling and evaporation. And let me inform, as many as those that will come tomorrow and Friday, give the assignment to them. I will not listen to, I was not around on Wednesday. On Monday, by the time I ask you to show, everybody must submit. And I will make sure the result will be sent to the coordinator and to send to the sponsors of this program. The SF and ASF will know that you are not serious if you don't submit. So that's just it. And it's not just writing. You will not just write and submit. You will defend it. At least if you submit, I can point to you to say what you have written down for me offhand. Please clap for him. I have not said he got it, but nobody forced him, and that's the scientist. Yes, you may be wrong, and you may be right. Always make yourself available to solve a question in the class or when you are at home. Don't be scared and don't consider a question tough. Now, and I told you, if a question is given to you, what you are expected to first of all ask yourself is, how many substances is the question talking about? If you look at the question very well, the question is only talking about two substances, hot water and warm water, or hot water and cold water. That's all. And if you are talking of hot and cold, I don't think you need to be asked which one loses and which one gains again. You ought to have known that hot water will lose to cold water. the temperature of hot water was labeled as T, while temperature of the cold water was labeled to be 30 degrees Celsius. When the hot water is now mixed with the cold, the mixture temperature becomes 50. You have to find the value. So starting from what you have just said, these are the information data. They said temperature of the hot water given as T, correct? Temperature of, to this you can call it cold water or warm water. That's initial temperature of the warm water. Then temperature of the resulting mixture. That's mixture temperature or steady temperature is 50. Fine. Now it lost by hot water equals it gained. This should be lost, so not lose. So it lost by hot water equals it gained by water, cold water. So if this is hot, you can turn this one to be cold water or warm water. Either you refer to it as cold or you refer to it as warm water. It's not as hot water. So now, that is the physics. You now try to find, you are given among the information, the mass of cold water is represented as M. Mass of cold water, you want to have mass of, okay, hot water. Let it be called M. Mass of hot water M. And you also have mass of cold water will be 2M. Twice of that. And that's what it did. The question stated it like that. So now, to calculate the heat loss by hot water with the mass of hot water, the capacity of water, change in temperature of hot water. And this one will be mass of cold water, so the capacity of water. The mass of cold water will now be, before you put these two, just say mass of cold water, so the capacity of water, then cold water. Now mass of cold water is 2M, mass of water is M. So it will now be this, then you substitute for 2M here, equal this minus this. So by the time you now do, you can divide both sides by MC, which is common to both sides. MC common to both sides. So you are going to have T minus 5 equals 2 times 20. And 2 times 20 will now be 40. Therefore, you take this one here, very correct. So give me your hand. From which school? Huh? That's good. And after this topic, we talk about pressure before we move to waves and optics and relative density of a substance. Very quickly, then we talk about pressure, density of a substance. That's the first one. Now, who want to define density of a substance? What do you understand by density of a substance? But let me first of all ask you this question. How many of you are hearing density of a substance for the first time? You have not heard it before. Raise up your hand. I have not heard density of a substance before. The word density is not heard. Raise up your hand. And if you have heard, what do you think density of a substance is? Or what is density? You have idea? Yes, you have something in mind. Yes, let's hear from you.
Density of the substance is the mass per unit volume.
Please clap for me. When did you do that? SS1. Not even SS1. You must have done it in basic science while you are in GS2, 3. GS3, 2, 2 or 3. Or mass of a substance all over volume of the substance. So density, you can simply put it as density of a substance can be defined as the mass per unit volume of the substance. Mass per unit volume of substance. That is, you can say density of a substance. Density of a substance equals mass of the substance all over volume of the substance. So the density can be represented as, this is usual way, density can be represented like this, or you use capital letter D. The mass represented by M, the volume is also, the volume is V. So we can simply write mass all over volume. That is the short form of this. So we can say the SI unit of density. The SI unit of density is kilogram per meter cube. Kilogram per meter cube. Other units is gram per centimeter cube. That's the other unit, which is smaller than the SI unit. So, and you can convert the other units to SI unit. How do we convert? You can simply say 1 gram per centimeter cube will now be equal to 1000 kilogram per meter cube. That's conversion. 1 gram per centimeter cube equals this. So if you are to determine the density of a substance, what do you have to do? You have to know the mass of that substance. You have to know the volume of the substance. And you now divide the mass by the volume of the substance. Before we proceed, can you tell me the devices that can be used to measure mass? Or how do we determine the mass of a substance? How do we determine the mass of a substance? How can one determine the mass of a substance? Want to raise? Yes, how do we determine the mass of a substance?
Using chemical balance.
Say it properly. How do we determine the mass of a substance?
By weighing it on chemical.
By weighing it on chemical balance. I give you about 4 different devices that can be used to measure mass. And there is nobody here that will not have gone to hospital before. And if you go to any hospital, whether standard or not, before you see doctor at all, the first thing they will do is to take your mass. They will measure your weight. That's the first thing the nurses will do before you even see the doctor. And some of your parents have this weight balance at home to measure your mass. And what is the instrument we use to measure weight of a substance? Yes?
The spring balance.
The spring balance. All these things, even if you claim other things are not taught in your school, what about the one way you are taught here? So, to determine the density of a substance, you can talk about the instrument that will be needed. You need the weight balance to measure the mass of the substance. And we have different forms of substances. Substance in liquid, substance in gas, and substance in solid. So different instruments can be used to determine their mass. For instance, if it is solid, you can suspend it. You can place it on the weight balance directly. But if it is liquid or powder, what you need to do is to look for a weight balance. Pan, scale pan, empty pan. You know the measure, the mass of their empty container. You now drop the liquid inside. You weigh the container with the liquid together. Difference between the mass of empty container and the mass of container with that liquid gives the mass of the liquid you are looking for. And even it's powder too, the same way you do. You put a pan or paper or whatever, take note of the mass of that container, pour the powder on it, then measure the mass of the container with the powder. Now subtract the mass of empty container from the mass of the container with the content, be it powder or liquid. That gives you the mass of the content. Very simple. But if it is solid, just put the solid on the weight balance. We have chemical weight balance like you mentioned. We have a liver balance. We have digital. We have direct reading, and so many other type of balances that can be used to measure mass of an object. So to determine the density, you need the weight balance to know the mass of the substance you want to find its density. 2, you need to know the volume. And you know, when we talk about volume the other time, during the coaching, during the campaign, we talk about volume, conversion of the unit of volume, how volume can be determined. You are told that we have regular shape objects. All regular shape objects have formula to determine their volume. To those of you reading constantly or revising all you did, that you understand what I mean. Those regular shape objects are also classified into 2. We have uniform and non-uniform regular shape. Be it uniform or non-uniform, they both have formula for their volume. For uniform, you can just say the base area of that substance times the height will give the volume of uniform shape object. For non-uniform, it is still the same way. The base area of that non-uniform times the height times 1/3. In other words, 1/3 times base area times height for non-uniform but regular shape. 1/3 times base area times height give the volume. Whereas if it is uniform, just base area times height give the volume of that uniform substance. And you are giving that time example of rectangular tank, that the rectangular tank is uniform. Rectangular tank is uniform shape. It's a good example of uniform shape object. The base is length times breadth, then multiplied by the height, give the volume of that. Due to the square shape, square tank, we have LL as base area, L square as base area. Height is L. So it's now going to be L square times L, which is L cubed. L cubed. So that's what you are going to have as the volume. A good example of non-uniform is a cone or pyramid. A cone has circular base, but the top is just a point, fattest, so it's not uniform. How do you get the volume of it? Just find the volume of the area of the base, which is circular. That's by R. 1 times pi r squared times height give the volume of the cone. Then with the pyramid, we have rectangular base pyramid. We have square base pyramid. How do we get the volume of that? It is also 1/3 times base area. If it is rectangular base, that will be length times breadth. 1/3 times length times breadth, then times height gives the volume of the non-regular shape. As apart from this, we still have other formula. We have other method which can be used for both regular and irregular shape, and that method is by immersion. The method is what? By immersion. You immerse the solid into a liquid. When an object is immersed into a liquid, that object will displace volume of liquid equal to its own volume. That object will displace volume of liquid equal to its own volume. And so we can now measure the volume of liquid displaced and use that volume of liquid displaced as the volume of the object that displaced it. Am I communicating? So you can now divide the mass of the object by the volume to get density. If I now ask you, maybe in the practical class, to go out and fetch a handful of sand and determine its density, that should not pose problem to you. You can just say go outside and fetch a handful of sand outside and come and determine the density of it in the lab. That should not pose problem to you. Will it pose problem to you? Can you do that? Then if I say determine your own density, can you determine your density? Is it possible to determine your density? Yes, sir. Can somebody tell me how his or her density can be determined quickly in the next 2 seconds or 2 minutes? How do you determine your own density? Yes, from which to?
Assurance. Chemical balance to determine the mass.
Can you start your chemical balance? Anyway, he has made a point, but that's the wrong instrument. He said chemical balance, beam balance. There is a weight balance. You have to measure its mass on the weight balance. All right. Yes, that's a good point.
To determine my volume, I will insert myself into a drum full of with water, and the volume of liquid that poured out of the drum or displaced, I will measure the volume of the liquid in the drum before entering it, and after entering it, I will now tell someone to measure the volume of liquid displaced in the drum. Then the volume of liquid displaced determines my volume. Then I will divide it, the volume. I will divide the volume. So I will divide the mass with my own volume.
Please clap for him. You know, I feel like giving my ATM card to him. Because unfortunately the ATM card I have is expired. So if I give it, will not be useful to him. But I've given him things to go and withdraw at least maybe 1,000 or 2,000. That's it. What he said cannot be read in your textbook. That's simply application of what I've just explained to you. And I'm sure might have asked you that question when you are calm. How to determine your volume? When we discuss measurement and unit volume. I'm sure I would have asked you that question, how do you determine your volume? Did I ask you that? There's only one that raised up his hand today. Can you see? And he got it correctly. When I say handful, fetch an handful full of sand outside and determine density, it's not in the first textbook you are carrying about. For application of what you have learned, which is it can be applied to other things. I can give this marker to you to determine its density. It's not a big deal. You don't need to see it in the textbook you are carrying before you do that. How do I know the density of the marker? I need to know the mass of it by weighing it. I need to drop it into the liquid to to know the volume of this. Then I will divide the mass of the marker by its volume. That's density of this. Density of the chair you are sitting upon can be determined. That's somebody who understands the concept. It's not just reading. Density can be defined as mass per unit volume of. Yes, it is. But you can apply so many things around you. So now I have told you the SI unit of density is this, while the other unit is this, and conversion. You must be able to. Let me talk you. This topic is a how do I put it? A lovely topic for jams. Then magnetism. That's electricity, aspect of electricity, where we talk about AC, DC, and what have you. I will rush you to get to that level before the close of this program. So, but this aspect, density and pressure, very simple. But many candidates used to mix the something together. So we started. After you have known this, the JAM will not give you unified units. They will give some unit in their SI unit, some other parameter will be given in other unit. I have told you and I've warned you time without number that all units must be unified before you substitute them into the formula. That's what we refer to as correct substitution. Change all parameters to their SI unit. In most cases, they will always give you mass in gram. You have to divide gram by. That's why you are taught measurement and unit at the beginning when you are calm. Centimeter squared. Where we have centimeter cubed here, you must take it to centimeter cube. Meter cube. So you see the question when we get to that level. So having said this, we have three parameters. 1, 2, 3. You should know that 2 out of 3 will be given to you. 2 out of 3 will be given to you. And the one that is not given will be the one you are asked to calculate. So that is that. Now we quickly talk about relative density. Relative density of a substance. We want to look at relative of a substance. Relative density of a substance. Relative density of a substance. Who can define relative density of a substance in the class? How many of you are hearing that for the first time? Relative density of a substance. Relative density of a substance can be defined as the ratio of density of a substance to density of water. So we have, that is substance equals density of the substance. Density of the substance all over density of water. Relative density of the substance is going to be density of the substance all over density of water. It has no unit. The relative density has it has no unit, or we can simply say it is a unitless quantity. Can someone tell me why it's a unitless quantity? Why is it unitless?
It's the ratio.
It is because it is ratio. And so it's the ratio that makes it to be unitless.
Because they are both in density and yes,
because the unit of will cancel the one below. They may be in ratio and not have the same unit. That does not mean that the unit will cancel out, even if you express them in ratio and they are not in the same unit. For instance, mass over volume is in ratio, isn't it? Is mass over volume not in ratio? Is it not in ratio? Is it a unitless quantity? No, it isn't because it's a ratio, that's why it's a low. It is because the unit of density above cancels the unit of density below. That's why it has no unit. So that is relative density of a substance. But liquid has other, before I give that of liquid, relative density of a substance can be defined this way. But we have other way by which we can express it. Please, to express is different from defining. To express is different from defining. If I say relative density can be defined as density of the substance all over density of water, that is its definition. However, it can be expressed, let's have it before you can say, however, relative density can be expressed as 1. The ratio of mass of the substance. The ratio of mass of the substance to mass of equal volume of water. The ratio, we are saying the ratio, it can be expressed. I'm not saying it can be defined again, though. So that when you have to define relative density, there is only one definition for relative density, and that is what we have given there. But it can be expressed as ratio of mass of the substance to mass of equal, well, I didn't say mass of water. That's it, relative density of a substance. Relative density of a substance equals mass of mass of the substance all over mass of equal volume of water. Mass of substance all over mass of equal volume of water. It can also be expressed as, you can change that to weight. So you can also say, or relative density of a substance equals weight of the substance. Weight of the substance all over weight of equal volume of Now, I want you to make the difference between this and this. This is simply defined as density of the substance over density of water. Definition of relative density. But I said it can be expressed as this, not it can be defined. It can be expressed as this. What does that mean? If I say it can be expressed as this, I'm sure as you are, you have names, and I believe you are all, if not all, majority of you are from Yoruba tribe, isn't it? Among those of you here, who is Hausa among you? Igbo. Okay? Now what I want to say will be clear to you. You have names, and you have what we call oriki. Do you understand what I mean by oriki? Who does not understand what I mean by that? Okay? So, your oriki is meant for a purpose. You can introduce yourself to your friend in the class and you mention your oriki. You can register your name in the school you have and put your oriki there. But why did they give you that? It's given for a purpose. When you have done something that impressed the grandpa or grandma especially, your mom or your grandma will call you that oriki. And when that oriki is mentioned, before they start saying your oriki, your own oriki will first of all mention. When that oriki is mentioned, what happens? Your head swell, you feel impressed. Arike, Ajoke, Akoni. Do you understand what I mean?
Yes.
I want response from you.
Yes.
So it means you use that for a purpose, and it is when that need for that purpose come that they use it for you. Now, come back to physics class now. This is like oriki. This one are like oriki to relative density. These are your common name, which you can use to introduce yourself. When you are in your class, you enter a school or you meet a friend newly. I am Yemi Adekombi. I am Shola. I am Ingwe. You will not say I am Alake. You understand what I mean? Even though that's your name. Now, this is the real name definition of relative density. But these are made for particular purpose. And what is that purpose? Calculation purpose. In other words, we make this or this, we make use of them when calculation arises. Some question we need them. You will need them to calculate some questions. It is when they are needed, you make use of them. But when somebody wants you to explain relative density, you cannot define like this. You give this definition. Just as you cannot tell your friend that you know I'm a kanji. So if your mate call you that akonji, you may be annoyed. But if your grandpa or grandma call you, you will feel impressed. When you suddenly heard that your result is released and you make A1 parallel, I'm sure your mommy will call you that name and you'll be extremely happy. It is used for such purposes. This one too are used for calculations. These are used for calculation. These are used for. Am I communicating?
Yes,
sir.
Now, there is one part, equal volume of water. What does it mean? It is not just mass of the substance all over mass of water, no. And it's not just weight of the substance all over weight of water, no. Equal volume of. And what does that mean? Who can try what it means? Who understand that statement? Equal volume. It is so simple. It means volume of the substance and volume of water will be the same, but their masses will not be the same. The ratio of their masses will now be the relative density. What do I mean? If you know the volume of the substance, if the volume of the substance is 200, fetch water of 200. Because the volume of the substance is 200, fetch water of 200. Know the mass of the substance, know the mass of 200 meter cube or centimeter cube of water. The ratio of the two masses is the relative density of the water. I mean of the substance you are talking about. Am I communicating? Equal volume of water. That means the water you are using here must have the same volume with the substance. The water here must have the same volume with this. The volume will be equal, but the weight of substance will not be equal to the weight of the equal volume of water. That means they have the same volume, but they will not have the same masses. And it's now the ratio of the masses that will now be called relative density. They must have the same volume. That's the word equal volume of water. Equal volume. Volume of the substance to the volume of water must be the same. That's what that statement means. Do you understand that now? You will come across questions where this expression will be needed when you start solving exercise. And that's why you are encouraged. That will not permit us to solve as many as possible exercise in the class. It is now open to you. You have the whole time to yourself to work many exercise, to bring difficult questions to the class. Even when we have gone far, we have finished the topic, we are taking another topic. If you have questions in any topic, the one we have done and the one we are yet to do, you are free to bring it to the class. That's going to show us that you are actually working hard. Not that you just come and go back, you are doing something on your own. So that is the relative density. This definition of it and two ways by which it can be expressed. But you don't know something. The substance we are talking about is solid. How do we find the relative density of a liquid? And the relative density of a liquid can be determined. Note that relative density of a liquid can be determined by dividing upthrust in the liquid by upthrust in water. So that means relative density of a liquid equals upthrust in liquid all over upthrust in water. Define upthrust in liquid all over upthrust in water. That gives relative density of a liquid. That gives relative density of a liquid. Then what is upthrust? Can somebody tell us what an upthrust is? Yes, only two people are responding. Let's hear from you.
Upthrust and upward force exert on an object in a field.
Please clap for it. Upthrust. Let me break it. Up. Something facing up. Thrust is a force. So when you say thrust is a force. The up means a force facing up. That's what we call upthrust. Thrust is a force. But up simplify that a force facing up. A force facing up is called upthrust. trust. Trust is a force. And therefore, trust will now have Newton as its unit. And like he said, it is a force in a given fluid. Upthrust exists in fluid. And what we mean by fluid is either gas or liquid. It means we can talk about upthrust in liquid. We can talk about upthrust in the gas, either air or any other gas. In fluid generally we have upthrust, and upthrust usually acts on every object immersed into the fluid. Every object immersed into the fluid will suffer upthrust. Upthrust will act on every object immersed into the fluid. In other words, if you immerse an object into the water, like the drawer is what we call a Femi from the well. When you drop the drawer, the Femi into the well, as soon as that drawer, the Femi gets to the well, upthrust will act on it. And that's why, if you have ever used the drawer before to fetch water from the well, you will notice that when the drawer is inside the well, inside the water, it will not be as heavy as when it is now lifted up. By the time it's lifted up of the water, it becomes heavier than the way it was when it's inside the fluid. The reason is not far-fetched. Upthrust supports the drawer while the drawer was inside the fluid. The upthrust in the fluid supports it, and that is why it looks lighter. When the drawer is right in the water, it looks lighter. But when the drawer gets off the water, it now looks heavier. That is, it will be heavier than the weight it has when it was inside the water. How many of you have experienced that before? And if you have not experienced, when you get back home to do that, the bucket too, if you use bucket to fetch water, you will notice if you are fetching from the pool, while it is in the water, it looks lighter. But when it is off, then it is heavier than what it was before. The reason is because of the upthrust in that fluid that makes it, because upthrust supports it, and it will now look lighter while it is in the fluid. So when we talk about upthrust, you know what upthrust is. That is just a force. It's an upward force found in the fluid and acted on every object that is immersed into the fluid. Every object immersed into the fluid will suffer upthrust. Like I said, they are the one responsible for the floating object. When the upthrust is equal to the weight of the object, the weight of the object will want to drag it down. The weight of the object acts downward. Upthrust acts upward. When the upthrust equals to the weight of the object can never sink. So, as I said, having known what the upthrust is, we want to now see a renowned scientist who studied and promulgated the law which was named after him. He studied and he promulgated the law, and the man is called Archimedes. Archimedes gave us the principle. How many of you have heard of Archimedes before? Everything you don't know, you have not heard of him before. You heard of Archimedes before?
Yes, sir.
Ah, that's interesting. He's a popular scientist. So we want to see Archimedes principle. What is Archimedes principle? Okay, let's hear it.
This principle states that when a body is totally or partially immersed into a fluid, it experiences an upthrust which is equal to the weight of the object displaced.
Please clap for her. How many people will I have given my ATM card to? Pray next time for me to bring the ATM card that work, that function. So she has gotten it correctly. Yes, Kadri, can you repeat what she has just said? What is Archimedes' principle?
Archimedes' principle states that when the body is totally immersed or displaced,
who can repeat what she has just given to us now in the class? One of you has just said something that you cannot, and you appreciated her by clapping.
This principle states that when a body is partially or totally immersed in the liquid, the upthrust is equal to the weight of the material substance.
Not exactly what you try. At least you say something. Yes, you raise up your hand. Yes, let's listen to you. Archimedes' principle states that when a body, please, when they say partially, there are many words you can use. Use convenient one that you think you can remember. You can say when it is partially or completely immersed, you are talking physics. Or partially or wholly. The whole body, that's what they mean by wholly, completely immersed. So the word you can remember, when a body is partially or wholly or completely, this can be or completely. Please, in the exam, don't write like this. Don't use the two words and slant it like this. No, pick one. I'm sure some of you will still be clean like that. Let me remove completely and put only wholly there. Or I put only completely. Partially or completely immersed. Immersed in a fluid. Then it will experience an upthrust which you can say the other way around, is equal to the weight of fluid displaced. Fluid displaced. Yes. It will experience loss of weight called upthrust, which is equal to the weight of the liquid displaced. You are still talking physics. It will experience loss of weight known as upthrust. If you put loss of weight, you can put upthrust in bracket, which is equal to the weight of the liquid or fluid displaced. Please let me call your attention to, don't use liquid here or use fluid here and now use liquid here. You need to be careful. Don't use liquid and fluid or fluid liquid. The best is to use fluid. Or if you want to say, you can say liquid. So that is just that. And if you say it experience loss of weight, open bracket upthrust, which is the upthrust, and it's equal to the weight of liquid displaced. That is physics. It was the Archimedes that let us know that Octros, according to Archimedes now, we now get a physics here that Octros, let me say, that is Octros U. That's physics that we must learn today. I'm sure you have learned it before, we have forgotten, but we must not let it go. Octros equals weight or fluid displaced. Place, that's a physics, and the weight is W. So I can abbreviate it to say Octros equals weight of fluid displaced. Fluid displaced. That's equation 1. Octros equals weight of liquid displaced. Equation 1. According to Archimedes. According to Archimedes principle, Octros equals the weight of fluid displaced. You can now get, since weight is equals to mass times acceleration, we can break this one down to, since W fluid equals mass of fluid displaced times G. Since WV equals this, therefore we can say Octros equals mass of fluid displaced times acceleration due to gravity. Call this equation 2. If you have to calculate the mass, that expression can give it to you. Then from what you have just learned a few minutes ago, mass, what you can also say, since density equals mass per volume, therefore we can say mass equals density times volume. So if I now say mass of fluid displaced can be density of the fluid times volume of the fluid. Therefore we can say Octros equals density of the fluid, volume of the fluid displaced times G. That's equation 3. Please, this is a powerful formula for JAM. Powerful formula for JAM. They can set question for you here. There are two things you may expect. There are two things you may expect. I mean, look at this. How many parameters are here? 1, 2, 3, 4. How many parameters? How many parameters? Good. These 4 parameters, only 2 of them can be varied. 2 can be varied. What do I mean by 2 can be varied? You may know one and they also have to find the other. These are the 2 that question may be asked, this one and this one. The other 2 must be given. Density of the liquid will be given to you. Acceleration to gravity will be given to you. But they may ask you to calculate the Octros when the volume of liquid displaced, volume of fluid displaced is given to you. What is the Octros? Am I communicating? This is jam questions. I'll give you a question now. This formula must be in you. Now, density of the fluid displaced, volume of liquid displaced, then acceleration due to gravity. The product of the 3 gives you the Octros. Or the Octros may be given to you and the examiner will ask to calculate the volume of liquid displaced. If the Octros is given and other 2, you are asked to calculate the volume of liquid displaced. This should not be a big deal, but many candidates find it difficult to do. You will come across it in past question, jam past question, where people find it difficult. Now, this is 3rd formula for Octros. Lastly, before I give working example, I want to also let you know that Octros can also be determined maybe you call that equation 4, can also be expressed, uptrust can also be expressed as lost in weight or the substance when it is immersed in the fluid. So how do we now do that? That is, we are saying upthrust equals, that's upthrust U, equals weight in air. When you weigh something in air minus weight in fluid. That's it. Or we say upthrust U equal actual weight minus apparent weight. Actual weight minus apparent weight. It means the same thing. We can abbreviate it by simply saying U equals weight in air minus weight in the liquid. If you have like this, weight in air minus weight in liquid will give upthrust in liquid. So if you need upthrust in liquid, you weigh an object in air and you also weigh the same object in that liquid to determine the upthrust in the liquid. You weigh an object in air and you also weigh the same object in the liquid. That means you suspend the objects. You suspend the object in the liquid and weigh it. The weight of the object in liquid is what we refer to as apparent weight. Am I communicating?
Yes, sir.
Are you sure?
Yes, sir.
So, if you know all these four equations, any question that upthrust Archimedes will get it. Is there any difficult expression among these? Let me give you a working example before we go on to flotation, principle of flotation. After flotation, then the next is to talk about pressure. An object of volume 60 centimeter cube was half immersed in water. Calculate the upthrust on the object. Take G to be 10 meter per second squared, and density of water with 1000 kilogram per meter cubed. You are taking that to be that. I read, an object of volume 60 centimeter cube was half immersed in water. Calculate the upthrust on the object. Take G to be 10 meters per second squared and density of water to be D. How many of us can solve this question? If I ask you to solve it, can you solve it? How many of you can solve this question? That's good. Only the girls. You can't solve it. Can you? Okay, let me solve it for you. Now, solution. I expect all hands up. I am giving volume of an object, that's VO, to be 60 centimeter cubed. Then acceleration G to be 10 meter per second squared. Density of water was given, of water, density of water 1000 kilogram per meter cube. Then I am to calculate upthrust U, not no. Very simple. But the question says 60 was half in mass. It means the object is not completely, it's not wholly in mass. It's not completely in mass. It's only half of it. Can somebody tell me the volume of water that was displaced when half of the object was immersed into the water? 30 centimeters. So that's good. So it means, if you look at it very well, object was half immersed. So the volume of object immersed will be equals to half times 60, which is 30 centimeter cubed, and this will be equals to, according to the Archimedes, this will be equal to volume of water that will be displaced, or that is displaced. 30 centimeter will be the volume, because 30 centimeter part of the object was inside. The space that object was occupying, the space the object was occupying the liquid that occupied that space before will now be sent packing. So, and that will be 30 centimeter cube of water. So the volume of water displaced now will be 30 centimeter cube. But centimeter is not the SI unit of the volume. So what we do now is to write out that the volume of water displaced is 30 centimeter. Now convert it to volume of water displaced equals 30 centimeter cube, which is equals to 30 divided by 1 million meter cube. So it means 30 times 10 raised by minus 6, and it becomes 3.0 times 10 raised by minus 5 meter cube. That is the volume of the water displaced. Now we are asked to calculate the upthrust. The upthrust on the object U. The upthrust on the object U will now be equals to, we said it earlier, density of water, volume of water displaced times G. So, and that will become 1000 for the density times 3.0 times 10 raised by minus 5. That's for the volume, then times 10. So you now have, you don't need to press calculator 1, 2, 3, 4. So this is as good as 10 raised by 4 times 3.0 times 10 raised by minus 5. That's it. So you now bring 4 and 5 together, This will be 3.0 times 10 raised to the power 4 minus 5. And that is 3.0 times 10 raised to the power minus 1 Newton. In standard form, but in ordinary you have 0.30 Newton. That is equal to the up thrust you have. That is the up thrust the object will suffer in this. Some people are just busy copying everything I am saying. They don't listen to what we are working. Next class we will ask simple questions, you will not be able to solve it because you are secretary in the class. And any questions on that? What is funny is if I quickly rub it and I ask somebody to come and reproduce it working, those people writing won't be able to produce the working. But it's only those that listen to explanation that reproduce the working. Without it, copy what you want to copy quickly and let's see what. An object was immersed in a liquid. Immersed in a liquid of density 150 kilogram per meter cube and experience and experience 0.8 Newton up thrust. What is the volume of the object? Take G to be 10 meter per second cubed per second square. Let's see example 2. Let's have example 2. An object was immersed in a liquid of density 1050 kilogram per meter cubed and experience 0.8 Newton up thrust. What is the volume of the object? Take this to, that's it. An object was immersed in a liquid of density 1050 kilogram per meter cube and experienced 0.8 Newton up thrust. What is the volume of the object? Take G to be 10 meter per second squared. Who can solve this question? Who can determine the volume? Okay, we are getting more hand. That's interesting. Well, because of time, solution. Very simple. Just get it like that. Now, we have density of the liquid DL is given as this kilogram per meter cube. We are given up thrust U 0.8 Newton. Then we are given acceleration due to acceleration G, 10 meter per second squared. That's the acceleration. We need the volume of the object. The volume of the object, O, is not known. But the physics you are taught now, how do we get the volume of object? You can calculate the volume of object, but you can calculate the volume of liquid displaced. So when you know the volume of liquid displaced, that will be equals to the object that displaces it. That is the object that is in mass. It is the volume of liquid displaced you will calculate. And you already know the physics there that once you have to get the volume of liquid displaced, it is going to be equal to the volume of object that displays the liquid. You get the volume of liquid displaced, you know that's the scale that has been given to you. The scale you acquired now is that volume of liquid display is equals to volume of the substance or object that displays it. So what we will say now is simply volume of the object will be equal to the volume of the liquid displaced. You can say but volume of liquid displaced. Volume of liquid displaced is VL, and that is not known. So when you get the volume of liquid displaced, that will be equal to the volume of object that displays it. But from the formula of upthrust that was given to you, we know that upthrust equals density of the liquid, volume of liquid displaced, and G. So from here we can get the volume of liquid displaced. We now equate it to the volume of object that displays the liquid. That is the physics. So upthrust is 0.8 as given, equals to density is 1050, then times volume of liquid displaced not known times 10. That's it. You make volume of liquid a subject of formula, so you are having volume of liquid displaced will now be equals to 0.8 all over this times 10. Like we other day you are told to work without calculator. You can also simplify this to 8 all over 1050 times 100. So as it is, you now reduce. You can reduce it. 2 here 4, 2 in this 5, 2 here 2, 5, 0, 0. That's what you have there. 2 can still go. 2 can still go. 2 here 2, 2 in this 2, 6, 2, 5, 0. 2 here 1, 2 in this 1, 3, 1, 2, 5. So you have volume of liquid displaced is equal to 1 divided by 1, 3, 1, 2, 5. So it is easier for you to quickly get this. So, and if you want to do, this is 13,125. So 13,000 in 1, that will be 0. In 10, 0. In 100, 0. In 1,000, 0. In 10,000, 0. Can you see that? So in 10,000 is 0. Now in 100,000, you are talking of 13,000 and we are talking of 100. So it's less than, in 100 you have, if it's 20 you have 5. So you have more than 5. That's the way you can quickly guess what is going to be the answer, even if you don't have calculator. Obviously, you're already having this. It is 200,000 now. This is 13,000 plus. So you have more than 6 or 5 something. So among the options, if it was to be jam, you already know which one has 0.004, I mean 0.40. Then the number must be greater than 5. So you check among the options to know what is going to be the answer. Now press that with your calculator. What do you have?
7.62
times 10 to the minus 5. You can see I've said it. Since this is not 20, if you are to 20 to be 5, so it means you are going to have number greater than 5, as you can see. So if this is ordinary number in standard form, it will be 7.62 times 10 raised to the minus 5 meter cube. That's meter cube. If you want to convert, if you want to convert it to centimeter, you multiply by 1 million. You multiply by 1 million. So it will now be 7.62 times 10 raised to the power 6 times 10 raised to the power 6 centimeter cubed. And that will be times this. It means 76.2 centimeter cubed. So you either have it in centimeter cubed or in meter cubed. To convert meter cubed to centimeter, you multiply by 1 million. But to convert centimeter cubed to meter, you divide by 1 million. This should be a simple thing that you know. Is that taken? So, example 3. An object weighing 50 Newton in air and 46.8 Newton when in mass into a liquid. Calculate the upthrust. Calculate the upthrust in the liquid. Now to calculate the upthrust in the liquid, let me have another marker. We have what is given in the question. Weight in air is represented by this and is given to be 50 Newton. Weight in liquid, that's W liquid, is given to be 46.8 Newton. That's it. We are to calculate the upthrust. Upthrust U, not known. But we know that you are given that upthrust equals weight in air minus weight in the liquid. Which is equals to 50 minus 46.8, and that will give you 2. This is 9. 9 minus 6,
3.
that's 3. upthrust will be 3.2 Newton.